recall what we have seen or what we have started in yesterday's lecture. So yesterday we have started with a chapter called as chemical equilibrium, and the continuation of that is nothing but the ionic equilibrium. Basically, the name of chapter is ionic equilibrium, and it is a continuation of chemical equilibrium. So, as we have discussed yesterday, ionic equilibrium is a very important, essential part in our daily routine lives. Number of things or many concepts in our daily routine life where we are concerned or where we are related with this ionic equilibrium. Biological processes, ionic equilibrium is very important. There are many industries where ionic equilibrium is very important. Ionic, there are some of the substances which produces ions when put into the aqueous solutions. And there are also some undissociated molecules. So there lies the equilibrium between this dissociated molecules and undissociated molecules. And that is nothing but you can say equilibrium. That's what you see. So in order to have the equilibrium, we should have a reversible reaction, or we know very well in reversible reaction, the rate of forward reaction is equal to rate of reverse reaction. And the state at which rate of forward reaction becomes equal to rate of reverse reaction, that state is called as a state of chemical equilibrium. That is what we are seeing. Yesterday we have seen that there are two types of substances. Substances can be classified as electrolytes and non-electrolytes. Electrolytes are the substances which put into the water produces ions, cations and anions. And non-electrolytes are the substances which do not produce cations or anions in aqueous solution, are called as non-electrolytes. For example, all acid, all base, and all salts are electrolytes, whereas sugar, alum, starch, these are the substances which are called as, you can say, non-electrolytes. So considering this fact, we have been gone ahead. And we also see here in the chapter, we are concerned with electrolytes more. Being electrolytes are the substances which produces cations and anions. That's why we are dealing with these substances. And general categories karte hai, to all acids, bases, and salts are called as electrolytes. That is what we are seeing. So whatever the acids, whatever the base, and whatever the salts we discuss, all they comes under this category. Now also, electrolytes can be classified as strong electrolytes and weak electrolytes. So also we have seen the definition, strong electrolytes are the electrolytes which dissociate completely, and weak electrolytes are the substances which dissociate partially. So that is also what we have seen. Then all strong acids, strong base, and salts comes under the category of strong electrolytes, whereas weak acid, weak base comes under the category of weak electrolytes. So that is also what we have seen over here. Clear with this? Then now today we have to continue with being acid, base, and salt are called as electrolytes. We know there are many examples of the acid and many examples of base, but the thing is that which substance has to be called as an acid, which substance has to be called as base. That has to be clear, and for that, different scientists from the different part of the world try to define the acid and base. Yesterday, you and I mentioned the thing that is called a classical theory of acid and base. While in the development period of the chemistry, there were properties of acid formulated. We have some properties of the acids and base, and the properties which were described for the acid and base were considered as a definition of acid and base. But that was not a classical definition. That was not a conceptual definition. That was just definition according to classical theory. So furthermore, there are some scientists come ahead and they define acid and base conceptually. Out of that, first is nothing but the Arrhenius, second is you can say Lowry and Bronsted, and third is nothing but the Lewis. So we have to define acid and base according to these theories, and then we'll go ahead. So let's move to the conceptual definition of acid and base. So number one, we are here for the definition of acid and base. We have to discuss acid and base. So which substance is called as acid, which substance is called as base? That's what we discuss here. So number one is according to Arrhenius theory. Okay, Arrhenius theory. So Arrhenius is the very important scientist and very genius scientist who define acid and base conceptually first time. And it's very easy definition. Already you know, you may be knowing this, but just we have to formulate again this definition. That is Arrhenius theory. According to Arrhenius theory, number one, what is acid? And number two, what is base? Okay. So I will give some example. First example, then afterwards we'll define a definition. So suppose HCl is the substance which produces H plus Cl minus, or here it must be aqueous. Here it must be aqueous, and here is you can say NaOH, which dissociate to produce Na plus OH minus. Again here, aqueous. AQ represents the aqueous for the water solution. So these are the two examples. According to Arrhenius, the substance which produces H plus ions, hydrogen ions in aqueous solution, that is in water solution, called as an acid. The substance which has the hydrogen and it produces H plus ions in aqueous solution must be called as acid. So very simple definition. जिस सब्सटेंस के पास हाइड्रोजन होता है और उसे पानी में पुट करने के बाद वो H plus ions पैदा करता है, that substance must be called as acid. And here we are the base. What is the base then? Base is the substance which, when put into the water, produces hydroxyl ions. Means base is the substance which has the presence of hydroxyl group, and when it is put into the water, it produces OH minus ions, hydroxyl ions, and this substance should be called as a base. So hope both definitions are very clear. These are very simple and easy definitions according to Arrhenius theory. So there are many substances, there are many examples what we can write over here. We can have the example of H2SO4. So we have H2SO4 which produces twice H plus aqueous plus SO4 2 minus. Again here aqueous. Next example is here you can say NH4OH dissociate to produce NH4 plus aqueous plus OH minus aqueous. So there are examples. There are many examples. Many examples. The substance which has the presence of hydrogen and it produces H plus ions in aqueous solution called as acid. And the substance which has presence of hydroxyl group and when put into the water produces hydroxyl ions, it must be called as a base. So simple definition according to Arrhenius theory. So hope everyone got it. Acid is the substance which has the hydrogen and produces H plus ions in aqueous solution. And base is the substance which has hydroxyl group which is present and it produces OH minus ions in aqueous solution is called as a base. So these are the two definitions according to Arrhenius theory for acid and base. It comes again to the neutralization reaction. It comes again neutralization reaction that is not listed in our book, but that has to be remember that it has to be recalled well because we need it for the JEE or Neet. What is neutralization reaction? You know already you know well that is acid plus base produces salt and water. Salt plus water. This reaction must be called as a neutralization reaction. So there is an example of acid. You can say HCl plus base is nothing but the NaOH, and it produces NaCl salt, and H2 is the water. This reaction is called as a neutralization reaction. Okay, so HCl is acid reacts with NaOH, which is the base to produce NaCl and H2O. NaCl is a salt, and this is water. So acid plus base produces salt and water. This is called as neutralization reaction. Modern terms में इस reaction को थोड़ा अलग तरीके से define किया जाता है. H plus HCl dissociate to produce H plus plus Cl minus and NaOH dissociate to produce Na plus and OH minus to produce. See, this H reacts with this OH to produce H2O, and this sodium reacts with chlorine to form NaCl. So this is what we can say. This is the reaction. So in that sense, you can say definition as a definition like H plus ions from acid reacts with OH minus ions from base to produce undissociated water molecule. This phenomenon is nothing but the neutralization reaction. तो न्यू थ्योरी के हिसाब से, लेटेस्ट थ्योरी के हिसाब से, मॉडर्न थ्योरी के हिसाब से, बिट हायर थ्योरी के हिसाब से न्यूट्रलाइजेशन रिएक्शन सिर्फ एसिड प्लस बेस प्रोड्यूस सॉल्ट एंड वाटर ऐसा नहीं है. H plus ions, मतलब according to Arrhenius theory, this is Arrhenius theory applied over here. According to Arrhenius theory, H plus ions from acid reacts with OH minus ions from base to produce NaCl and H2O. This reaction is called, you can say, neutralization reaction. So that is what we can say here. So first is Arrhenius theory, who defined acid and base, and next is the neutralization reaction. That is what we have. First concept. Let's move to the second concept given by Lowry and Bronsted scientists. So acid and base according to Lowry and Bronsted. See, these are the two different scientists. Lowry and Bronsted. They are two different scientists. One is from Denmark, one is from England. So these are the two different scientists from the different parts of the world put the same theory at a time. Same theory at a time, and that's why it is a combined theory put forth before us. That is the Lowry-Bronsted theory. So this theory also tried to define acid and base. So what is the acid according to this theory? What is the base according to this theory? That is what we are discussing. So let's move. Number one, what is acid? And number two, what is base? See, the substance is the same, but different theory define this acid and base a bit differently. Again, I will give one example first, and then we'll define the definition. It becomes easy. So this is HCl reacts with NH3, gives you NH4 plus Cl minus. ये रिएक्शन हम लोगों को मिलता है। अभी देखिए पहला रिएक्शन हम डिस्कस करते हैं यहाँ पे. So HCl is the substance which reacts with ammonia to form ammonium plus ions and chlorine minuses released. This is the reaction of HCl. इस रिएक्शन के अंदर आप देखते हैं हम लोग तो दिस इज द सब्सटेंस जो HCl है. यहाँ पे NH3 यहाँ पे 3 हाइड्रोजन यहाँ पे 1 हाइड्रोजन है. प्रोडक्ट में दिखता है कि दिस नाइट्रोजन के साथ यहाँ पे 4 हाइड्रोजन है यहाँ पे 1 क्लोरीन. तो इसका हाइड्रोजन इसके साथ चला गया. तो इट हैज डोनेटेड हाइड्रोजन टू दिस NH3. HCl has donated hydrogen to this one, and hydrogen is nothing but the proton. Hydrogen is also called as a proton. That means this is the substance which has donated proton. So this is the substance which is a donor of proton, and this is the substance which is acceptor of the proton. So according to this Lowry-Bronsted theory, the substance which donates a proton is called as acid, and the substance which accepts a proton is called as base. So that is what we can say. Acid-based definition. We need not have another example for this one. This, a single example is sufficient. Hope everyone is getting well. Whether you are able to see my handwriting as well as you are getting my voice well. So, so here this is the example in which we have defined acid and base also. So according to Lowry and Bronsted theory, the substance which has the capacity to donate the proton is called as acid. So acid is a proton donor. And base is a substance which accepts a proton. That is, you can say proton acceptor. So, according to this theory, so simple definitions of acid and base are there. According to Lowry-Bronsted theory, the substance which can donate a proton is called as an acid, and the substance which can accept a proton is called as a base. So, proton donor is acid, and a proton acceptor is base. That is the definition of here. So, with a single example, we can have the clarity of both of the concepts: what is acid and what is base. So, this is the proton donor. As it has donated proton to this substance, so this becomes acid, and it has accepted the proton, and that's why this base becomes the base. So acid is a proton donor, and base is a proton acceptor. This is the example of the HCl according to Lowry and Bronsted theory. Now, let's further concept of this theory called as you can say conjugate acid-base pair. Conjugate acid-base pair. Okay. Same example आता है. That is, you can say HCl plus NH3 gives you NH4 plus Cl minus. So, being this HCl donates proton, this is acid. It accepts proton, that's why it becomes base. Okay. So, this is what we get here. Now, the thing is that these are the reactant and these are the product. If we observe this example well, will comes from these are the reactant and these are the product. So what happens here? This is the HCl and this is the NH3. Now this substance donate a proton to this one and it accepts. Afterwards, this substance is NH4 produced and this is Cl minus produced. Okay. This is a forward reaction. While going to backward again, reaction backward hota hi hai. That is reversible reaction. This has 4 hydrogen. This has nothing, no hydrogen at all. So while in the backward direction, this NH4 plus donate a proton to this one. This donate proton to this one. So it becomes NH3 and it becomes HCl. So while in the reverse reaction, it is a proton donor. That's why it becomes acid, and it acceptor of proton. That's it becomes a base. So once we call this is acid 1, acid 1 forms. This is the base 1, and whereas this acid 2 forms base 2. So acid 1 से base 1 मिलता है और acid 2 से base 2 मिलता है. This is what we can see. ऐसा मत कीजिएगा कि this is called as acid 1 and this is called as base 1. Never. The reason behind that we are discussing conjugate acid base pair. How it is? See, this is the substance which is called as HCl. HCl simply by donating a proton gets converted into Cl minus. That is into the base. So this is the acid. Just by donating a proton gets converted into base, and this is the base. Just by gaining a proton gets converted into acid. So acid से base बनता है और base से acid बनता है just by losing or gaining proton. This is the beauty of this concept, and that's why it is called a conjugate acid-base pair. This acid 1 and this base 1 must be a conjugate acid-base pair. The reason behind that, this acid gets converted into base just by donating a proton, and this base converted into acid just gaining a 1 proton. Similar like here, see this is the acid 2. This is the acid 2 which in this reaction donates proton and converts into base, And this is the base converted to acid by accepting the proton. And so that's why this pair is called as a conjugate acid-base pair. This pair is called as a conjugate acid-base pair. So in this reaction, we have two conjugate acid-base pairs. Or कौन सा conjugate acid-base pair होता है? The substance, the acid, which gets converted into base by donating proton, and the base which converted into acid by accepting the proton. That is called a conjugate acid-base pair. Clear with this? So here are the two theories what we have seen related with this acid and base. Number one is RNA theory. Number two is nothing but the Lowry and Bronsted theory. RNA theory के अंदर हमने न्यूक्लिएशन रिएक्शन भी डिस्कस कर दिया और Lowry Bronsted theory के अंदर हमने conjugate acid-base pair भी हमने डिस्कस कर लिया. ठीक है. Now let's move to the third theory जो मैंने बताया था आपको. That is nothing but you can say Lewis theory, which is very important again. Lewis theory. So Lewis theory की तरफ चलते हैं. That is nothing but third theory. Third, Lewis theory. Lewis is also one of the very important and very genius scientists here in chemistry. Many concepts he has put forth, and these are widely accepted throughout the world. So, Lewis theory is also very important theory regarding the acid and base. This is very generalized theory. काफी general theory है और काफी general तरीके से उन चीज को define करता है. That is called as Lewis theory. Let me give one example. As you can see here, we have ammonia. This is ammonia. H, H, and H. मैं थोड़ा structure के format में निकाल रहा हूँ. And this is BF3, boron trifluoride molecule. Now, this nitrogen has lone pair of electron. It donates lone pair of electron to this one. What the structure? This is nitrogen, hydrogen, hydrogen, hydrogen. And here bond is formed between boron, fluorine, fluorine, and fluorine. Okay. So, this is we can say the substance form. Now, देखिए, ये simple reaction. This is simple reaction. In this reaction, what happens here? This is the substance called as ammonia, and this substance called as boron trifluoride. The reaction occurs between ammonia and boron trifluoride, and this complex is formed here. Coordinate complex or coordinate compound is formed. That is called as a coordinate complex. So what happens here? Just observe this reaction. How the bond is formed between nitrogen and this boron. How the bond is formed between nitrogen and boron. This nitrogen has lone pair of electrons which is present over here. This lone pair of electron can be donated to this boron. Lone pair of electron can be donated to this boron. And then the bond is formed between them. ठीक है, यहाँ पे भी ये भी bond दिखे. बोरॉन के साथ 3 फ्लोरीन अटैच्ड है, उनके साथ भी मैंने bond दिखाया. नाइट्रोजन के साथ यहाँ पे 3 हाइड्रोजन अटैच है, उसके साथ भी मैंने bond दिखाया. लेकिन यहाँ पे देखिए नाइट्रोजन और बोरॉन के बीच में जो bond दिखाया वहाँ पे एरो लाइक स्ट्रक्चर है. ये एरो टाइप का बॉन्ड होता है. दैट्स कॉल्ड ए कोऑर्डिनेट बॉन्ड. बाकी जो बॉन्ड है वो अलग बॉन्ड है. दैट मे बी आयोनिक बॉन्ड और दैट मे बी कोवैलेंट बॉन्ड. बट दिस इज द वे हाउ द coordinate bond is shown. There is one chapter called as coordination chemistry. In that you have discussed that part. So this is called as coordinate bond. Out here is coordinate bond is formed by donating a lone pair of electron by any one of the atom to another. So here is the nitrogen which has this lone pair of electron, and this lone pair of electron can be donated to this boron. Boron accepts the lone pair of electron, whereas nitrogen donates the lone pair of electron, and the bond is formed between them. Whatever the two electrons needed for the bond formation are donated by one of the atom. हम अच्छी तरह जानते हैं there are types of bond. Number one is covalent bond. What is covalent bond? Then the bond which is formed by sharing of electrons. So for every bond we need 2 electrons. We know well. And if these electrons are shared between the two atoms, that is called a covalent bond. Suppose bond is formed by complete transfer of electron from one atom to another atom, develop positive negative charges, and then they are held together due to electrostatic force of attraction. That is called an ionic bond. So ionic bond is the bond between oppositely charged ions. Covalent bond is the bond which is formed by sharing of electrons, and this is coordinate bond in which both electrons are donated by one of the atom. So nitrogen has lone pair of electron. It donates this lone pair of electron to boron, and the bond is formed between them. So this arrow pointing towards boron indicates that. Arrow is very meaningful. This arrow indicates that this lone pair of electron which this nitrogen has, it has donated it to boron for the bond formation. So it indicates the direction of change, how the electrons are, who has donated this electron and who has accepted this electron. So that's why coordinate bond is always shown with the arrow. That means that these electrons are donated by nitrogen and are accepted by boron. And that's why this bond is called a coordinate bond, and this compound is called as a coordinate compound or coordinate complex. So here we are, our main concept is nothing but acid and base again. So we have to discuss who is acid here in this example, who is base. According to Lewis theory, the substance which donate a lone pair of electron must be called as a base. So this is nothing but base, and this is nothing but the acid. So according to Levy's theory, the substance which donates a lone pair of electron is called as a base, and the substance which accepts lone pair of electron is called as an acid. देखिए पहले दोनों theory में पहले दोनों तरह आयोनिक theory की बात करते हैं, लोअर कॉन्स्टेंट theory की बात करते हैं हम लोग, वहां पे प्रोटॉन डोनेट किया जाता है बाय द एसिड. ये पहला theory है जिसके अंदर एसिड एक्सेप्ट कर रहा है, वो भी लोन पेयर ऑफ इलेक्ट्रॉन, and base donate कर रहा है वो lone pair of electron. So base is the substance which donate a lone pair of electron, and acid is the substance which accept a lone pair of electron. So simple definitions. Also, everyone get the definition? According to Levy's theory, acid is the substance which accept a lone pair of electron, and base is the substance which donate a lone pair of electron. So base donate lone pair of electron, and acid accept a lone pair of electron. These are the definitions of acid and base according to Levy's theory. Hope so you are clear with this one. हम जैसे स्कूल शुरू किए थे, हम स्कूल लाइफ से अच्छी तरह जानते हैं कि हम एसिड बेस को जानते हैं. मैं पूछता हूँ और बच्चों को एग्जांपल दे दो तो you will give the examples. HCl is acid, H2SO is acid, but why that is defined as acid, or according to which concept it is called as acid? That must be a conceptual definition, and we know it very well. According to this, either Arrhenius theory, either Lowry-Bonstein theory, or according to either this Levy's theory, acid and base is defined. Now, one thing is also very clear: which theory has to be accepted. There are three different theories, and तीनों अलग-अलग तरीके से उस definition को define करते हैं acid base. कौन सा theory accept किया जाता है? So there are many concepts which can be explained on the basis of Arrhenius theory. There are many concepts related with acid base can be explained on the basis of Lowry-Bonstein theory, and there are some of the concepts of acid and base which can be only explained on the basis of Levy's theory. All these theories, three theories are used because the property of acid do not changes, even though this conceptual definition may be different. ये भी याद रखिएगा, though acid and base is conceptually defined by different theories, different ways, the properties of acid and base do not change. Property change नहीं होता है. What are the properties according to classical theories described for the acid? What are the properties described for base? These never changes. As we have seen, acid is corrosion reaction. Acid turns blue litmus to red. Acid reacts with active metal with evolution of hydrogen. Acid is a sarin test. All these are the properties which do not changes, which never changes. Though acid base is defined differently by different things. So wherever we need some more extra explanation on all, these theories perfectly suits over there. So they are used. तीनों theory use किए जाते हैं as per the need and as per the explanations where we need it. So उसी तरीके से चले जाते हैं. Clear with this? So hope everyone got it. There are three definitions or three different theories which try to define the acid and base. So according to Arrhenius theory, what is acid? Acid is a substance which has hydrogen and which donate H+ ions in aqueous solution. What is base? Base is the substance which has presence of hydroxyl ion and it produces hydroxyl ions when put into the water. According to Lowry-Bonstein theory, acid is the substance which donate a proton and base is the substance which accept a proton. And according to Levy's theory, acid is the substance which accept a lone pair of electron and base is the substance which donate a lone pair of electron. एग्जाम में आपको कभी नहीं पूछेंगे कि डिफाइन एसिड एंड बेस, नहीं पूछेंगे. आपको पूछेंगे डिफाइन एसिड एंड बेस अकॉर्डिंग टू Arrhenius theory, डिफाइन एसिड एंड बेस अकॉर्डिंग टू Lowry-Bonstein theory, define acid and base according to Levy's theory. तो carefully पढ़िएगा. We have to define acid and base according to which theory. Whatever accordingly carefully we read it, accordingly we have to define this. तीनों में से कोई भी पूछा जा सकता है. Clear with this? That's what we can say. इस Levy's theory के अंदर और कुछ points आते हैं जो important है. Because Levy's theory is very very general theory. There are hardly any reaction. There is hardly any reaction where there isn't any exchange of the electrons. So there are most of the reactions, there are most of the changes, there are most of the chemical changes which are due to the exchange of the electrons, or where the exchange of electron donation or acceptance of electrons is completely involved or clearly involved. So that's why this Levy's theory is a very general theory. दुनिया के सारे रिएक्शंस के अंदर किसी न किसी तरीके से इलेक्ट्रॉन या तो दिए जाते हैं या तो इलेक्ट्रॉन लिए जाते हैं. इलेक्ट्रॉन के एक्सचेंज ना हो ऐसा कोई भी रिएक्शन आपको मोस्ट प्रोबेबली रिएक्शन यहाँ पे नहीं मिलेगा, केमिस्ट्री में नहीं मिलेगा. In that sense what we can say, Levy's theory is called a very general theory, and that's why it's applied to many of the substances, many of the concepts. So as we have seen, acid is the substance which accept a lone pair of electron, and base is the substance which accept, donate a lone pair of, lone मतलब single, pair मतलब pair, तो single pair donate करता है या accept करता है. So that is so according to this Levy's theory, there are many concepts which arise, or there are many classifications what we can have here. So मैं वापस उसी को थोड़ा सा और एक्सप्लोर करना चाहूँगा इस चीज को, ताकि जेई नीट के ऊपर ये बहुत इंपॉर्टेंट है. जेई नीट के लिए ये खास Levy's theory बहुत इंपॉर्टेंट है. कई सारे कॉन्सेप्ट्स आते हैं, एटलीस्ट एक भी तो Levy's theory के ऊपर आ ही जाता है. अब देखिए As we have seen, what is active? We have seen what is base. According to this thing, according to Lewis theory, acid is the substance which accept lone pair of electron. Base is a substance which donate lone pair of electron. सवाल ये donate कौन कर सकता है? Base. It should be electron rich species. All electron rich species must be base. So these are electron rich species. Number one. So base must be electron rich species. Whenever it has electrons, then only it can donate. So that's why it is electron rich species. It must be electron rich species. And here, the electron deficient. Electron deficient species. So acid must be electron deficient. When it has electron deficiency, then it can accept it. If you don't have the electron deficiency, it won't accept. So that's why base must be electron rich and acid must be electron deficient species. So दुनिया के जितने सारे electron deficient species हैं, these are called as acids. और जितने सारे electron rich species हैं, that has to be called as base. अभी electron deficient मतलब कौन होता है? All cations all are positively charged. That means they are electron deficient. Here all anions मतलब they have the negative charge. Cations की बात करते हैं हम लोग जैसे कि sodium plus ion, aluminum 3 plus ions, है ना, NH 4 plus ions, like this one 4 plus ions. These are. Here हम बात करते हैं SO4 2 minus, O2 minus, then Cl minus, OH minus. This has to be, you can say, collegial. These are the some examples what I have listed. There are many examples what we can put over here. These are the some examples what I have listed. All cations here in this world, all cations has the scarcity of electron, has the deficiency of electron. That's why they act as acids. All anions, they are electron rich species, and that's why they must be act as anions over here. There are some neutral species. Which are neutral, but though they are electron deficient species. So जैसे कि हम लोग बात कर रहे हैं यहाँ पे तीसरी बात आती है कि BF3 molecule, then you can say BCl2 molecule. These are the substances which are acting as electron deficient, though they are neutral species. Here, there are some electron rich species that you can say PCl5, SF6, then ammonia, then water. So there are some examples of these species, what we can see. Right. So these are the substances which are neutral, but they're acting as a base according to Lewis theory because they have the extra electron, they have the more electrons. This electron can be donated, and that's why they are acting as base. And these are the species which are electron deficient, though they are the neutral. Now, on what basis we are going to define this one? So this can be defined on the basis of, you can see. One thing is very important here. This BF3 and BHL2 molecules when we discuss here, these are incomplete octets. In chemical bonding, in 11th standard chapter, we have seen that is octet rule. So what the octet rule defines, we know very well. According to octet rule, every substance tries to complete 8 electrons in its outermost orbit by gaining electrons. Every substance tries to complete 8 electrons in its outermost orbit by gaining, or sharing electrons. That is called the octet rule. So here, boron forms 3 bonds with fluorine, and it gets 3 electrons from the fluorine atom. So boron has its 3 electrons, fluorine has noted 3 electrons. It has total 6 electrons in its outermost orbit. As of now, being it has a 6 electrons, it is incomplete octet because octet, in order to complete octet, we should have 8 electrons in the outermost orbit, but it has only 6 electrons, and that's why it is an incomplete octet. All the substances in this nature which has less than 8 electrons in the outermost orbit, even though they have one molecules, even though they have the associations, till then they are electron deficient species, and that's why they are acting as a Lewis acids. They are electron deficient because they are incomplete octets. Here, these are the substances which are called as expanded octets, more than 8 electrons in the outermost orbit. And that's why they are electron rich species, and that's why they can donate a lone pair of electrons for the bond formation. And that's why these are called as Lewis base. So most of the substances here in this nature, here in this world, can be classified as Lewis acids and Lewis bases. So the substances which are electron rich are called as Lewis base because they can donate a lone pair of electrons. So all anions are electron rich. All expanded octets, though their molecules are neutral molecules, they have lone pair of electrons, and that can be donated. That's why they are acting as a Lewis base. And the substances which are electron deficient, all the substances here in the nature which are electron deficient must be acting as a Lewis acid. All cations has the deficiency of electron, and that's why they act as a Lewis acid. As well as there are some neutral molecules which have incomplete octet. Though it is a neutral molecule, they do not have completed the 8 electrons in the outermost orbit, and that's why they are electron deficient species. And all the electron deficient species must act as a Lewis acid. So this is very general definitions according to Lewis, and that's why it's very important, because there are many substances we can classify as Lewis acids and bases. So as far as JEE Neet is concerned, this competitive examination is concerned, these type of general and very vague concepts are very important, where they will ask you classify the following substances into Lewis acids and Lewis bases. So we should know the conceptual definition of acid and base according to Lewis theory. We should know the Lewis theory well, then we can easily classify the substances. So if that substance is a neutral substance, then it's become a bit difficult to classify either Lewis as a Lewis. So we have to go into the octet rule concept. So either its octet is completed or not. How many pairs of electron it has and it can donate. So depending upon that, either it will act as a Lewis acid or Lewis base. So that is the very important classification or definition what we can have here. Clear with this? So that is very important part. Clear with this? So hope so everyone got it. That is what we have yesterday started with electrolytes, and electrolytes are strong electrolytes and weak electrolytes, both comprises of acid, base, and salt. So here in today's lecture, we have tried to define what is acid and what is base according to different theories. There are 3 theories what we have discussed. Number 1 in RNS theory. Number 2 is nothing but the Lowry constant theory, and number 3 is nothing but the Lewis theory. And we also defined neutralizing reaction, conjugate acid-base pair, and the classification of substances into acid and base according to Lewis theory. That's all for today. See you tomorrow. Thank you very much. Bye-bye.